Hi, we will consider how to solve inequalities that are of this form. This is a quadratic inequality, and these two inequalities are the same. So I've put it there just to let you know that if you were given this equation, the first thing you want to do is to factorize it and put it in this form. Generally, if you're solving questions for an examination, usually you'd expect that they will give you an inequality that can be factorized. Okay, so you factorize it and put it in this form, and then we are ready to begin. Now, the best way to look at this graph is to consider it in columns, and what I mean by that is this will be the first column, and this is the middle column, and then you have the third one. So what we want to do is to pick any x value from the first column, and we are picking only x values because the question is asking us to find the range of values of x for which this is negative. Less than 0 means negative. Okay, so we will choose a value from this column. It could be any value of x at all, as far as we choose it from that column. Okay, and then we're going to test it by putting it into this expression, and if having solved it we get something that is negative, we will be sure that the range of values of x for which that is less than 0 will be found in this column, basically. Okay, and what do I mean by this column? The first column contains all x's that are less than -3. Okay, because this is -3 and every other x's towards the left will be less than -3. In the middle column, what you have there are every x's that are between -3 and 5. So you write it as this, between -3 and 5. We will not put the equal sign because it's not in the question. What we have there is strictly less than 0. In the third column, we then have all the x's that are greater than 5. So we begin by testing values of x in the first column. If x is less than -3, it means that x could be -4. If we put that in this expression, we then have -4 plus 3 multiplying -4, -5. And then -4 plus 3 will give us a negative value, which is -1. And -4, -5 will give us -9. If we take that product, when we have 9, because -1 multiplied by -9 will give +9, and +9 is greater than 0, which means that our solution is not contained in the first column. In the second column, we could choose x to be 0 because between -3 and 5 you will find 0. There are other numbers that can be tried. For instance, you could try using x equals to 1. It will yield the same result. So when x is 0, if we put 0 plus 3 and 0 minus 5, and we take the product, we will have 3 multiplying -5 to give us -15. -15 is less than 0, which means that this portion is where we have the solutions for our inequality. Can we Now consider x that is greater than 5. If we choose a 6, for instance, and we put it into this expression, we will then have 6 plus 3 and 6 minus 5. And if we maybe simplify that, we will have 9 multiplying 1, which gives us 9, and which is greater than 0, which contradicts this as being less than 0. So this tells us that our solution cannot lie in the third column. The range required is between -3 and 5. Okay, I hope this makes it simpler, and I hope that you understand it better. Here is a second example. I've chosen not to plot a graph this time around because we should be able to continue with the example without considering the graphs. Okay, so if we have this, the first step and the first thing you want to do is to factorize, and if you do that, you will have 3x minus 5 and then 2x plus 3 to be greater than 0, which means that our roots will be at 5/3 or at -3/2. Okay, now remember I said we should treat the graph page as if it were in columns, because the first root is, what I mean by the first root is the smaller root. The root that demarcates the first column of the graph will be the smaller one, which is -3/2. We will begin with that. So we will look at every axis that are less than -3/2. And then we will look at every axis that are in between -3/2 and 5/3. And then we would also consider every axis that are greater than 5/3. I hope there is no confusion here. And if there is no confusion, we will consider a value of x that is less than 3/2. 3/2 is 1.5, so this is -1.5. A number less than that could be 2. And if we put 2 in this expression, we will have 3. We'll have 3 times 2 minus 5 multiplying 2 times 2 . Okay, a value that will be less than -1.5 will be -2. So what we want to do is to put -2 in this expression and see if it's going to give us a value that is greater or equal to 0. So 3 in -2 and then -5, and then we find the product with 2 in -2 plus 3. 3 multiplied by -2 will give us -6, and then we are subtracting 5, and we also have -4 plus 3. This gives us -11, and this gives us -1. If we multiply these two, we get 11, which is greater or equal to 0. Hence, the value here satisfies this inequality. Okay, if we choose a number between -3/2 and 5/3, we could also test for this column, and such number is 0. If we pick 0 and we multiply by 3 and deduct 5, and we also multiply by 2 and we add 3, we should have -3 multiplying 3, and this will give us -15, which is less than 0, which means what we have here is greater than 0. So we would conclude there that there is no value of x between -3/2 and 5/3 that satisfies this inequality. The next thing to test is for every x that is greater than 5/3. 5 is a number that is greater than 5/3. So 3 multiplied by 5 minus 5, and then 2 multiplied by 5 plus 3 will give us 15 minus 5, and then 10 plus 3, and this gives us 10 times 13, which gives us 130, which is greater than 0. Hence, the solutions that we seek will lie either to the left of -3/2 or to the right of 5/3. Remember that this is actually greater than or equal to, so we should change all that and change the signs properly, which is really important. I hope this example has made things clearer. Here is an example that you can try by yourself. So you could pause the video and take a look at this and see how you do. Welcome back. What I would then try to do is to solve it myself, and then you can compare that with your answers. The smaller root will be -6, and the greater one will be 1. If you ask me how that is, you have x minus 1, okay, to be less than 0. Okay, so what we want to do is to then consider every x that is less than -6, and then we would also consider every x that is between -6 and 1, and every x that is greater than 1. Okay, so that I show you how some of these things might appear in your textbooks, I'm going to put the factors like so, just by the side, so that you see how we can make this much more organized when solving. Okay, now this is the first column, and then the middle, and then the last. So if we consider x less than -6, we could look at when x is -7. -7 is less than -6. If we put in -7 here, and then we deduct 1, it gives us -8. Hence, this will be negative. If we put in x equals to -7, here you have -7 plus 6, and that gives you -1, which means this is also negative. If we find the product of negative and negative, it gives us a positive, which means this is plus. Okay, and which means this is greater than 0. And we have less than 0 here, so we do not have the solution amongst the x's that are less than -6. For the middle column, we could choose x to be equal to 0. If we do that, we would have 0 minus 1, which is negative. Here we would have 0 plus 6, which is positive. And if we multiply a negative by a positive, it gives us a negative, which is less than 0. Hence, this represents the range of values of x for which this is less than 0. To end this, we would consider when x is greater than 1. We could choose 2 as our sample number. So if we take 2 and we deduct 1, it gives us 1, which is positive. If we take 2 and we add it to 6, it gives us 8, which is positive. If we multiply positive by positive, it gives us a positive, which is greater than 0. This contradicts what we have here. Hence, we do not have the solution here or here. And the range of values of x for which this expression is less than 0 will be found between -6 and 1. This is where we stop this session. I hope to join you again next time. Bye bye.